So, welcome everybody. So good to see you all here in real life. How was the keynote? Did you like it? Yes? Cool. So did I. I loved it, actually. So let's get started. So, I have a problem. I've fractured my motivation. And I'm going to tell you all about it, but not before I first fix another little problem I have. Because I'm not sure about you all, but I don't really like those abstract examples, foo, bar, baz. I'd rather keep things real. So let me first give you a whirlwind introduction into our problem domain, and then I'll get back to the real problem. So yes, we're a web shop. We sell products, and we put those products on the list page, so you can easily browse and navigate through them. And our REST service is, amongst other things, responsible for delivering titles or headings of the page. And to do so, it needs to have a little bit of context. In this case, a list page context, which gives our REST service context on the category that has been selected by the user. In this case, films and series, and the possibly empty list of refinements by which a user, a consumer like you, could further narrow down its selection. For instance, a year of appearance or spoken language of the film. So, well, that's everything you need to know. I'll be using this list page context, those categories and refinements all along. So now let's get to the real problem. So like I said, we have a REST service which receives requests in JSON. It uses a library that implements the business logic, and this library is not only used by our REST service, but also by other clients, by other consumers. It does fetch the category information from a different service. So it has a REST interface. Let me shrink that a little bit. It uses JSON annotated objects to represent the JSON payload. Okay, well, if you don't know what JSON is, I'm not talking about Michael Jackson. I'm talking about the Java JSON library for mapping Java objects to JSON. So on the left-hand side, you have one of those JSON annotated objects, and on the right-hand side, you have this JSON format, and JSON does nothing more than marshalling, unmarshalling between them. Very useful. So right, JSON annotated objects. We have even more JSON annotated objects, because also the category that comes from the other service is just JSON. We have domain objects that live inside the REST service, and we have even more domain objects that live in the library. And that's a lot of dull code to write. So in particular, we have 18 endpoints, 18 requests and 18 response objects, 18 internal domain objects that live in the REST service, and then there is more. We have around 18 domain objects that live in the library. And there's even more dull code, because yeah, we need to map all these JSON annotated objects to our domain models, and from the REST service domain models to the library domain models. And yes, that fractures my motivation. That breaks my enthusiasm. Not sure what it does to you, but for me it does. So that made us wonder, can't we actually automate this problem away? Well, luckily, the answer to that question is yes, absolutely, we can. And in this presentation, I'll show you exactly how we approach that problem. So first, I'll start by explaining you how we generated our API models, how we generated our domain objects. Then I'll explain you how we generated the tedious mappers. And after that, I will generate a conclusion. Optionally, you may generate an applause, but that's totally up to you. And then there is hopefully some room for questions. So, okay, wait a minute. I'm quite sure there is at least one of you, maybe more out here, who thinks, hey, come on, man, why even bother writing these boring domain objects? Why not just use those JSON annotated objects? I mean, they're already there, right? And you also generated them. You can explain that in a few slides. Well, let me ask you a few questions. So, are all the fields from our API actually needed in our domain model? Do they make sense there? And what about the other way around? Well, I can tell you they don't, in our use case. What if we add, rename, or delete the fields from our API, from our domain? Could that break our API? Well, I think it might. And what if we want to switch to another API generator? do all those Jackson annotations actually make sense in our domain model? I don't think we want to pollute it with those Jackson annotations. And what if we want to define another API or media type based on the same business logic? For example, what if tomorrow we want to go back to Google Protobuf? Let's not do that. And what if those Jackson objects are actually mutable rather than immutable? And I'm going to show you in a few slides they are actually mutable, and also going to explain you why immutability to us is very important. So right, onto API code generation. So in this part of the presentation, I'll show you how we auto-generate those 18 endpoints and how we also generate the code for those 18 request and 18 response objects. So we adopted an API-first approach, and that allows us to design, mock, try, and discuss our API endpoints with our consumers before writing a single line of code. Auto-generating a single line of code. So, and for that, for doing so, an API specification comes in quite handy, because it's a specification for describing, producing, consuming, and visualizing RESTful web services. I just stole this from Wikipedia, by the way. So let's have a look what such a spec looks like. So here you have the OpenAPI design of our endpoint, which basically is a YAML file, and it consists of the URL of the endpoint. There's a accept language header, a request parameter. There is a request body, which is, in this case, a list page context. And we define that elsewhere in a different document. There it is. So the list page context, which consists of a category, which is mandatory because it should have minimal length of 1. You can also put a nice example in there. And there is the refinements the user has selected to further refine the selection on the list page, which is required. So the API-first approach, like I told you, is a nice tool to already discuss your API endpoints before even auto-generating a single line of code. So let's do that. Let's auto-generate this code from the specification. And to do so, we found two candidates. So we found Swagger CodeGen and the OpenAPI generator. So let's first start with Swagger CodeGen. It's an open source project that is able to generate server stubs, also able to generate client code. We're not using that. We're only generating the server stubs in our in this presentation directly from an OpenAPI spec. And then there is the OpenAPI generator, and then things actually become quite interesting. It's like a soap, because the top contributors of the Swagger CodeGen project, well, they didn't really like where this whole Swagger thing was going to. So what they did is they kind of defected, and they just forked the Swagger CodeGen project. And now it's a project that's driven by the community, which has similar functionality as the Swagger CodeGen project, but has a more rapid release cycle. So if you look at the GitHub commit history, the commit activity, then you'll indeed see that when the fork took place, that's around 2018, early 2018, there you see that actually, all the attention moved to the OpenAPI generator, so things became a bit quiet at the Swagger CodeGen project. And that made us decide to just start with the OpenAPI generator and see how that works, just experimenting with it. So how does that work? Well, you have to do two things. First off, you have to put your OpenAPI specs in the resource folder. Yes, like this. And then you have to define the OpenAPI Maven plugin. It also comes as a Gradle plugin, if you like, but we use Maven, so there it is. You need to tell it, amongst other things, where it can find your API specification, your OpenAPI specification. We tell it to use or actually ask it to use the Spring and Spring Boot generator, because that's what we use in our projects. But, well, this generator actually supports a myriad of different languages and frameworks, like Kotlin, Python, and there's Jersey, REST-EC, etc. And then, finally, we ask it to generate our domain models, or Jackson annotated models, and also our API endpoints. Run the Maven clean compile, and bang, look at all those lines of code I didn't have to write myself. That's quite a lot. And this is not all, actually. So good, let's have a look at how that actually maps onto the code. So remember, this is the design of the endpoint, the OpenAPI spec, consisting of the URI, accept language header, and request body. All this is translated into or generated into an interface with a method, and unfortunately, we didn't figure out yet how to auto-generate our business logic, so you have to implement that method yourself. That method is annotated with the URL mapping, the accept language input parameter, and the request body. And like I already hinted, we didn't have to write that ourselves either, because the list page context specification that consists of a category ID and a list of refinements is also being auto-generated into a Jackson, oh gosh, annotated class. Yes, right. The list page context, there it is. So there you have the category ID, list of refinements, and which are all accessible through getters and setters. And like I said, setters, so this is in fact mutable, and I'm going to tell you why we don't really like that later. And as a bonus, it comes with a nice Swagger page that's accessible through the browser and allows you to already play around with your endpoint, fire requests at it. You can see the responses, dummy responses of course, unless you implement a business logic. And that's really a useful tool to communicate with your clients. And test it yourself, of course. So, to summarize, the OpenAPI generator is a good fit with the API first approach. Really useful because it keeps your design and code in sync. If you change your design, generate it, and it will generate the code for you. And you get a Swagger page for free. And you don't have to write any code. That was the whole point, right? It also has some disadvantages. The Swagger annotations are generated by default, and, well, I might be wrong, but I couldn't find a way, or we couldn't find a way to actually get rid of that. We don't mind, but if you do, well, it's kind of mixed in between Spring annotations, Java annotations, and Swagger annotations, so you might not like that. Sometimes we got a bit lost in configuration options, because there are a lot of them, and they're not always that well documented. We stumbled upon a few bugs. Actually, at some point, we had to move back to the Swagger codegen plugin because we stumbled upon a bug that was not in the Swagger codegen. And then later on, when it was fixed, we could move back again. So yeah, if you hang in there long enough, good things can happen in this world. I mean, look at me. I'm presenting a JFall now. So in this part, we've seen how all these 18 endpoints, 18 requests and 18 response objects, bam, all auto-generated. So let's have a look at how we generate the domain objects also. So in this part, I'll tell you how we auto-generated the 18 internal domain objects that live on a REST service, how we use the same framework for generating the library code, domain models. So let's start with why would we even want to generate domain objects? Well, kind of no-brainer, it saves time, right? Because you don't have to write these tedious getters, equals, copy methods, hash code. It's all being automatically generated for you. It leads to cleaner code because you can focus on the things that actually make up your domain model, the attributes. And you, well, if the getters and setters are there, I don't know about you, but I just can read through them anyway. And now you don't have to. It's easier to maintain because if you add a field, it automatically updates all your boilerplate code. And it leads to safer code because if you pick the right framework, it does actually quite well handle null. So picking a framework was actually easy for us in this case, because in the past someone already decided to use the Immutables framework in the library. It's kind of no-brainer because, well, it works, it's already there, no learning curve, so hey, why not use it? All right, well, just for the sake of this presentation, I'll just pretend we did our research first, okay? Deal? So then, if you do, there are three popular choices. To start with, there is Project Lombok to spice up your Java code. Surprise, there is Immutables. And there's Google Auto Value. All right, yeah, so I'm pretty sure that someone here is asking like, okay, yeah, nice, but all those frameworks, but they're all based on Java, so why not move beyond Java 11 and have a look at data classes or records? Because indeed, there are more choices beyond Java 11. However, our project uses Java 11, so record types are not an option for us yet. We already had Immutables set up in the library, so yeah, like I just explained, that's why we picked the Immutables framework. But I'll first focus on comparing Lombok immutables and auto value, and then I'll get back to data classes and record types, I promise. So we compared those three frameworks on their ability to generate boilerplate code, because that's the first thing we're looking for, not having to write code, create and update objects, and particularly to what extent they support the builder pattern. I'll explain that later for the ones who are not aware of that pattern. And to what extent it can deal with supporting full immutability. And I'll also explain why immutability is so important to us. Let's first start with the boilerplate. So if you look at auto value and immutables, then you'll see that it does generate all the boilerplate code for you. You just have to write a simple specification, some annotations, and you're done. And it does actually generate human readable code. So you can just like read through the code. It's like almost if you've written the code yourself. Lombok also generates all the boilerplate code out of a simple specification. But it does generate classes by modifying the bytecode of the original class. And yeah, that's a bit controversial, also a bit scary. Because what it actually does, it just like takes your compiled code and it merges the bytecode of these getters, setters, and all the code into it. And as a consequence, you cannot view your generated Java class easier. There are plugins to do that. And it can be difficult to integrate with an IDE, and it's not easy to generate Java docs because, yeah, it's bytecode. So, in our opinion, auto value and immutables are the best pick when looking at this property. Right, so let's have a look at to what extent they do support builders. So, the builder pattern, it just gives you a fluent way of constructing objects. So instead of using a constructor with rather meaningless parameters, like 1, 2, 3, what does that mean? Is it the ID? Is it something else? Is it the name? You don't know by reading that code. If you use the builder, which is depicted on the last part of the slide, then you see that it's way more fluent, because now I know that 1, 2, 3 is actually the ID, and that red is the value name. Doesn't matter if you don't know what it means, but you see at least what parameter it belongs to. That's the point. So now when it comes to builders, there are actually two ways of defining a builder, or actually two types of builders. We have normal builders and we have staged builders. So is this actually readable? In the back, yeah? Cool, nice. So the first example, so here you have 3 examples of a builder. And the first one is exactly the same as I used on the previous slide. The second one is almost the same, but now I just switch the order of the fields around. And in the third example, I just forget to set the ID. So let's assume the ID is actually a mandatory field. Now for normal builders, all 3 examples will happily compile. But we'll throw, the third one will throw a runtime exception. I think it's a null pointer. If you trigger the build method, if you invoke the build method. For stage builders, however, and that's a good thing, only the first will compile. So the second and third won't compile. So the third one that actually causes trouble at runtime with a normal builder, well, it's already called by the compiler. So one does not simply forget to set a mandatory field when using stage builders. That's the key point. And that's why we like them. So now, to what extent do those frameworks support builders and stage builders? Well, Lombok does support builders, if you just use an annotation. There is no support for stage builders, however. At least I can find it, we can find it. Auto value, builders are supported, but well, you need to manually create something that's called a builder interface. So there's still a little bit more code to write. Less code than if you would have to write it all manually, but still more code. And stage builders, well, it boils down to writing even more code. Immutables does generate builders automatically and supports normal and stage builders. So again, we think immutables is the best pick, for our case at least. Right, so finally, let's have a look at support for full immutability. So why is immutability so important to us? Well, an object is considered immutable if it cannot change its state after you create the object. So it will be the same and it will stay the same after that. And that has a bit of some advantages. Well, first of all, you have simplicity, because it's easier to reason about your code. Doesn't matter to what algorithm you pass your object, it will remain the same because it cannot be changed. So no side effects. It's thread safe. You can just like share it with different threads, and you don't have to worry that one thread, while the other is processing it, changes your object. And because of that, you don't have to worry about locking if you use immutable objects. So that improves your concurrency performance. And yeah, our application is highly concurrent. And you can even share their state. You can cache them, and that makes it more memory efficient. So now, when passing mutable lists to builders, like we do here we create a mutable list, an empty mutable list. And we pass it on to a dummy builder. Now the builder either can use the reference to the list directly, and that is a shallow copy, as depicted in this picture. So here we have a variable pointing, referencing an array. It's called values. Now we assign values to another variable, data. So values and data will both point to the same array or list. Or the builder, alternatively, second option, can create a deep copy that's wrapped in an immutable list. Like this. So here it just copies it and has its own private immutable instance of the list. So now when passing mutable lists to builders, like I said, so here we're passing this mutable empty list to the builder. Now when we add an item to this list, then question to you, will this test pass if we made a shallow copy of the list? Raise your hands if you think it doesn't. Nice. It doesn't. The size will be 1 because you're basically changing the same list. So under the hood, your model has the same list. And it's good to know that Lombok and AutoValue both make shallow copies. And what if we made a deep copy? Then it will pass because you have your own private view of the list, your own private instance. And then it's good to know that Immutables does make a good copy, does make a deep copy, and actually wraps it in an immutable list. So of course this comes with a little bit at a price of a bit of performance, but as you've seen, the Jackson annotated objects, which we like to convert to our domain model, well, they're mutable. So to us, it's important that this list is actually immutable, because otherwise someone else could still have a reference to the list and change it. So you don't have full mutability. So therefore, still believe that immutables is the right choice. So let's see what it looks like. Well, this is actually a whole specification you have to write for our list page context. You just have to provide an interface. You define 2 getters, one for the category ID, one for the refinements, and you annotate the whole thing with a value immutable from immutables. You compile it, and bam. Again, all the code we didn't have to write ourselves. And that's actually a lot because, well, this example, it's not only the category and refinements. So think of all the things you could do in the time you just saved. And that's why I don't want to tell my manager we're doing this, because, hey, I mean, I can either lay on the beach or have 2 jobs. That's totally up to you. So yes, I made a promise. So what about those data classes and records? Well, let's first have a look at the data classes. To what extent can they save us from having to write this boilerplate? Well, with a data class, a Kotlin data class, we only have to type in this. Data class, list page context, two values, category ID, refinements, and Kotlin, the compiler, will take care of the rest for you. Yes, that's what I said. All the boilerplate code's generated. So that's a good thing. I like that. I really like that about data classes. What about the builder pattern? Well, Kotlin doesn't support builders. You can build them yourself just like you can do in Java. But actually, that's not a big deal because the name parameters from Kotlin really make up for that. And here you see why, because now, well, I'm just using the constructor. So this is in Kotlin, I'm using the constructor, and I can actually tell you what the 1, 2, 3 is. You can see that from the code, it's the category ID, and you can see that the list of refinements is empty. And also Kotlin's null safety is great. I really like that feature, because actually both lines won't compile. So in the first line, I deliberately set the category ID to null, and on the second line, yeah, I just omit it, so it will also be null. And the compiler won't accept this. It will punish me for doing this. And that's great. I really like that. But in Java, however, and remember, our project is on Java 11, we don't have name parameters. So the fluent way of building an object in Kotlin, which look like this, kind of lost when we do the same thing in Java. Because there we only have constructors, and again, we have those meaningless parameters. And we only have one. So you also have to pass in the last optional field. And also Java does not have a concept, a notion of null safety. So this line that won't compile in Kotlin is happily accepted by the Java compiler. It compiles. It doesn't run, gives you a null pointer exception, but hey, it compiles. So yeah, all the strength of Kotlin is actually lost when you use those data classes in Java. So when you're using Kotlin, don't get me wrong, go with data classes. They're awesome. Kotlin is awesome, but yeah, just not if you're in a Java project. I wouldn't recommend using it. At least it doesn't fit in our project. So now, what about Java records? So what about the boilerplate reduction? Well, a record basically looks the same as a data class. Where did they get that from? How does it support the builder pattern? Well, records only accept one constructor with only the components of the record. And that means that in this case, there will only be one constructor accepting the category ID and the refinements. Either it be nullable or not, doesn't matter. And what about the support for full immutability? Well, it does support immutability by default, but it does not make a deep copy of immutable lists, because it's just like any plain Java object. It works the same. But there's actually more to mention about Java records. Well, records come with restrictions because they have like really crisp semantics, and I won't go into that, but I really like that. I think it's a good choice. But as a consequence, there are some restrictions. It doesn't have mutable fields, which we like. That's what we're looking for. But also, there are no extra fields that are not part of the constructor. So you can't have a private field in a record. No derived attributes. So that's impossible to do. Also, one cannot, a record cannot extend from another class. It's simply impossible because under the hood it's actually extending from a record type. So, yeah, records might not be able to fulfill all our domain model needs. They're very useful in certain use cases, but yeah, for modeling domain models, it might not always be the best fit. So also for us, we don't believe that the frameworks we just discussed, like Lombok, AutoValue, and Immutables, will be replaced by Java records. But let's see, we might be wrong. So in the end, laziness does pay off, because still Immutables seems to be the right choice for our particular use case. So in this part, I show you how we generated those 18 domain objects, how we auto-generated those 18 domain objects that live in the library, Yes, all auto-generated. No single line of code. Well, okay, a few lines of code. So do you guys still have some energy, and girls, by the way, still have some energy left for the last part? Yeah? Wow, tough crowd. That's a good thing. So finally, in this last part, I'll tell you how we also dealt with the problem of generating those mappers, mapping from the Jackson annotated objects to the internal domain models, and from the REST service domain models to the library domain models. And we noticed that in most of the cases, the models are actually like twins. They're almost similar, having the same structure, having the same fields, and there are a few exceptions, because that's why we used like different models in the first place. And that actually again made us think, hey, there should be a way to overcome this, so can't we automate this whole problem away? Well, again, the answer is yes, we can, because there are a lot of mapping frameworks out there, each relieving you from the tedious task of writing this boring mapping code yourself. There's Dozer. There's JMapper, there's Orica, there's MapStruct, and there's Model Mapper. So wow, that's 5. So which one to pick? Well, this time, unlike Immutables, we did our research first. So first had a look at framework performance, because yeah, performance is really important to us. We had a look at community involvement, how many people are actually contributing to the project, how alive is the project still. And finally, we had a look at ease of use, because yeah, I mean, replacing one tedious task by another, that doesn't make sense, does it? So what about performance? Well, luckily, we didn't have to go through all those, sorry, Johan, boring benchmarks ourselves. That work has already been done for us, because we came across this excellent blog post, and it does make a really good comparison of all those mapping frameworks I just mentioned. So let the metrics speak for themselves, I would say. So if you look at the throughput, the number of operations per millisecond, well, you see that JMapper and MapStruct are way faster than Orica, Model Mapper, and Dozer. And when looking at the average runtime in milliseconds per operation, you also see that MapStruct and JMapper are magnitudes faster than those other 3. So we have a tie. It's either JMapper or MapStruct at this point when looking at performance. Too bad for Dozer, because I really like that name, Dozer. So what about community involvement? So let's have a look at the GitHub activity of MapStruct. There are of course more ways to check the community involvement. This is one way to look at it. And here you see that there is actually, as of the beginning of the project, it's 2013, yeah, till today, there is like a steady line of commits and an active user community. If we look at JMapper, however, not so much. After 2017, not much happened. Just in case you wonder what the blue line is over there, that's the sound a cricket makes. So we have a winner. We have MapStruct. Woo! So, but what about the ease of use then? Like I said, does it make sense to replace one tedious task by another? And there's actually only one way to figure that out, right? Just start using it. Like Sander said, go experiment with it, keep it small, and that's just what we did. So we started by just writing a few mappers for some real objects in our project and evaluated afterwards. So in particular, we tried mapping our REST service domain model, the list page context and the category context internal, to their counterparts that live in the library. And we just played around with it a little bit. So in particular, we tried mapping multiple sources to one target, mapping optional fields, mapping object hierarchies, and of course builders, because yeah, I mean, we were so happy with them, so it should support at least builders. But let's start with a simple case, the case of the identical twins. So here we have a category, and we like to map it to the other category that lives in the library, and you see that it has the same structure and exactly the same fields, same names, same types. Easy peasy. Well, in this case, we just have to define an interface, our category mapper, annotate it with the special MapStruct mapper annotation, and we have to ask MapStruct to generate a tulip or map method for us that maps the internal category to the library category. Again, compile, and bam, there we have it, a generated mapper. So let's have a closer look. So first off, we see that MapStruct did implement our interface. It also annotated it with a Spring component, and that's configurable. We use Spring, so that's pretty handy. It did implement our method, our mapping method. It indeed uses a builder. It straightforwardly passes all the fields from one category onto the other, onto the builder of the other, and finally it returns a build category object. So key points: it generated human readable code, annotated a mapper with a Spring component. It also works with lists and nested objects. I did not show that in the example, just to keep it short and simple for the slide. You just have to take my word for it. It works. And it did support builders out of the box. And now, I have to be honest with you, because it does not support staged builders. And yeah, I really hate that. It's a shame, but we had to let go for staged builders. But on the bright side, we only had to write one interface with one method, and in this case mainly because the objects are like identical twins. But what if they're not? What if some fields are actually different? Well, would this still be a simple case if the category ID on the left-hand side is called ID, and on the right-hand side it's named differently, category ID, spelled out full? Well, in that case you only need to tell MapStruct. You just need another annotation to tell that the ID is actually needs to be mapped onto the target category ID. So if you have like a lot of domain objects which do have different fields, yeah, you end up writing a lot of those mapping annotations, and then you might maybe as well write them yourself. But for us it works because the models are almost identical, almost. And what about mapping multiple sources to one target? So in this case we have a list page context which has the refinements the user selected, and we have the category which is fetched from a different service. And those need to be combined in the library into one list page context, which has both the category and the refinements. So how does that work? Can MapStruct deal with it? Well, we just have to specify that two sources, the context and the category, are mapped onto one target, their library counterpart, which encapsulates both. And this just works out of the box. It's amazing. Now, what about mapping optional fields? What if the category can actually be null? And this is a real use case we ran into, because it can be null. And then, well, we like to map it to an optional category in the library. So would this mapper still work is the question, if the category can be null and it needs to be mapped to an optional. Well, we kind of ran out of luck here, because this is MapStruct gently telling us that we're doing it all wrong. But luckily, it also gives a hint on what is missing and how to fix it, and that's pretty helpful. But first, let's see what the problem actually is. So remember the category mapper I just shown you a few slides back? Yeah. So the problem is that this is not an optional, so MapStruct cannot figure out how to reuse this method. It just auto-generated. And the thing is, we just have to tell MapStruct how to map it. So we need to help it by defining a method that defines, in this case, how we can map an arbitrary object, which can be null, and wrap it into an optional field, and then it works. And actually, we can lift this method to a reusable mapper class, so you only have to write this once, so you don't have to write this for all the classes. And that's pretty good. So now, lastly, let's have a look at the ability of MapStruct to map object hierarchies, because what I didn't tell you before is that refinements actually come in different flavors. So we have range refinements, and that's basics, well, for example, a price slider you selected, ranging from 10 to 100 euros. Then we have delivery period refinements. I want to have this product delivered tomorrow or today. And identity refinements are, well, let's say it like this, basically everything that's not a range or a delivery period refinement. And also here, the hierarchies are actually quite similar, looking at the source and the target we're mapping here. So now the question is, can we actually do with one method for the base class? Can we do something like this? So we only tell MapStruct that we want to have a refinement to library refinement, and it figures out how to map all those subclasses. Who thinks this works? Raise your hand. Oh, not many people have faith in MapStruct, or you all fell asleep. Well, the few were right, it doesn't work. So let's start with what MapStruct can do. It is able to actually generate mapping methods for each subclass. So let's make use of that. So what we did here is we just specified the mapper for each subclass case. So for instance, the first line, we define the mapping method for the identity refinement, do the same for the range and delivery period refinement, and MapStruct will actually generate the mappers, because this is the case it can handle. And then, well, we're just left with writing the base class mapper ourselves, which boils down to doing an instance of check. In this case, we're checking if it's an identity refinement, and if it is, we just call the method that's being generated by MapStruct. So just a little bit of boilerplate code. Now, if you're not impressed by these instance objects, well, so are we. Yeah, I won't dive into that into this presentation, but there's actually another way. I've wrote 3 blocks about MapStruct, which are really in-depth and, well, describes the whole journey and all the silly things, because we ran into quite silly things with MapStruct. And you can find all those blocks and many more interesting articles, shameless plug, on techlabbol.com. So, at last, and don't go there now, because I have a few more slides left. So at last, I've shown you how we auto-generated those 18 mappers for mapping the Jackson objects to our REST service domain model, and how to map the REST service domain model to the library model. All auto-generated. Yay. So time to generate a conclusion. So the OpenAPI generator relieved us from having to write our API boilerplate code. Fits well with an API-first approach, and keeps your design and code in sync, which I really like. If you want to know more about API first, Vasco Veloso will have a talk about OpenAPI and API first at 4:55 p.m. I'm not sure which room he is, but I'm going to attend the talk as well. So it might be interesting. And then there is Immutables. That framework saved us a lot of time by auto-generating cumbersome domain object code. Generates fully immutable objects, has lots of annotations which provide out-of-the-box functionality, and finally, I talked about MapStruct. That alleviated us from the tedious task of writing mappers that are as fast as the code you would have written yourself. And if you want to know more about MapStruct, Joris Kuiper will give a talk about MapStruct, an intro to MapStruct at 4:05, so I hope I didn't tell everything he's going to tell. So please do tell my manager I generate all my code, because it leaves me with the time for the fun stuff, the things that actually matter, like writing documentation. Yay. So thank you for listening. And if there are any questions, now's the time to ask them. So, any questions? Yes. I'm sorry. Why the number 18? Yeah, why not 42? Well, that's actually the number of endpoints we have, so no lie. It's really the amount of methods and the amount of code we have, yeah. So, any more questions? Yeah, probably, yeah. I saw there is like 1.5, we're still on 1.4, and it did fix... Sorry? It's in the making currently, and it does support inheritance. It does. Oh, that's great. See, that's why you should pick a library that has community support, because of that. Well, thank you. I didn't know that. Any more questions? Yes, right in the back. I'm sorry. Why we care about the result, if it's human readable? Yeah, that's a good question, actually. Well, for the case of MapStruct, sometimes it didn't do what we did want it to do, and it did do quite, well, silly stuff, I have to say. I actually found a bug where it had an if statement, and then it checked for the same, inside the if statement, it checked for the same condition with another if statement with an else, so that else is basically unreachable and will be optimized away by the compiler. So yeah, in some cases it can be quite handy to see the code. That's one reason. And another reason is that in this case, because I believe, I haven't done any investigation, but for the mapping frameworks, I think those 3 slow ones are actually based on reflection, and that makes your code run slow. And this does actually generate code that's not based on reflection, which is human readable and just very fast because of it. So that's another advantage. Does that answer your question? Yeah, cool. Yes, Niels.
Do you have a clue why the OpenAPI generator generates those API annotations?
Sorry? This,
You showed
yeah.
auto-generated code with mostly annotations, API parent, API this.
Yeah.
Why would you need that?
Oh, that's a good.
Why not just a plain interface with no annotation?
Yeah, that's a good question. I don't know. It's just what it generated, and it works for us. So we didn't really dive into that, but I'm definitely sure that you know more about this. Being the main contributor of MotorMount. Yes. Oh, that's a good question. Like, yeah, but then you have to annotate them, right? Yeah, I'm not sure if you can do any annotations. Maybe you know, Maurice, because you also know a bit more about immutables. Is it possible to like weave in your annotations?
It does have Jackson support.
Yeah.
I'm not sure if it has hibernate support.
Okay.
It has excellent documentation.
Yeah, that's true. Yeah, quite a lot of it actually. Yes. Yeah, I'm not sure, but yeah, then again, I can ask the question: do you really want to? Why not like keep those models separate? I mean, do you really, is your database model actually the same as your internal model? But yeah, that's totally up to you, of course. I mean, it's a matter of taste, I guess. Ah, right, yeah. Yeah, it might not work. I'm not sure if Hibernate, because I know like Jackson likes the setters, so it likes things to be mutable, yeah. Yeah, that's probably true, because otherwise it has to resort to reflection, which you obviously don't want, yeah.
It has support for MongoDB.
Oh, it does, oh.
On MongoDB.
Well, okay, well, that's one thing. It does have support for MongoDB. Thank you. Are there any more questions? Yes. Sorry, yeah.
I'd like to use records, MapStruct to use records as DTO. So from the entity with MapStruct DTO. Would you consider that? You can have records there.
Ooh, I haven't tried if that works actually, so it does.
But it doesn't, you cannot do everything. You can't do after mapping because when you map your record, it's
Yeah.
final.
Yeah, exactly. You can't do anything with it. Yeah,
Yeah.
doesn't have builders. Yeah.
Yeah, but in the constructor of the record, you can create an immutable class, but you can just say to the constructor, copy it instead of just using the reference. So I find it is a nice solution. But maybe it will fit in your code generation using DTOs like that.
Yeah, I think it's an interesting use case. It's worthwhile trying. Yeah, and we might do if as soon as we move to Java 17. So you also had a question. Yeah, exactly. Yeah, so it's, yeah, you're right. Yeah, it's kind of chicken egg. Yeah. Yeah, that's true. Well, it does have its advantages, but yeah, I mean, in my opinion, it should be able, if you don't like it, then it should be turned off. That's why I'm telling it. But for us, it works. So I'm not sure how am I doing time-wise. It's 1 minute, so one more question, I guess. Anyone? Yes? I'm sorry, can you speak up a little bit? Yeah. Well, that's a good question. So, no, I don't know. Well, we're using REST. That's the only thing we're doing. I don't have experience with things like GraphQL. So yeah, I'm not sure if it makes sense there, but I'm pretty sure that either it's supported or there are probably other frameworks out there, because that's the whole point, right? Just like have a look what's out there, because there are things that can generate code for you. And depending on your project and your different use cases, particular use case, well, just pick the right model or the right tool to do the job. Right, thank you.